Good morning, sir. Good morning, classmate. I am Judy A. Flores from BSED 1A, and my topic for today is all about detecting of nuclear radiation. But first, let us define what is nuclear radiation. Nuclear radiation, also called ionizing radiation, is a type of energy released as a high-speed charge, particles, or electromagnetic waves. Radiation can come from both many resources, sa natural man, or even sa mga manufacturer. There are some types of nuclear radiation, which is alpha, beta, and gamma rays nga gidiscuss na sa akong gisundan nga reporter. But ang karon nga akong i-report is all about detecting a nuclear radiation ra. There are 4 ways to detect nuclear radiation. First is photographic film. Second is Geiger-Müller tube or GM tube. Third, scintillation. Fourth, cloud chamber. Let's proceed na sa photographic film. So, what is photographic film? Photographic film is still the most common detector of ionizing radiation being used routinely in medical and dental or even X-ray. Nuclear radiation is also called a film, such as seen in the video. The mechanism for film exposure by an ionizing radiation is similar to that by photons. Kibali, ang photographic film is kabantay mo anang ng mga X-ray. Di ba kabantay mo anang X-ray nga mura siya og kanang naa siya itom nga mo pag magpa-X-ray ka mura siya na mo reflect nga itom, which is radiation detectors ay na siya kanang magpakuanta sa atong baga or even nga kanang something nga mo reflect siya. What types of radiation does photographic film detect? Unsa daw nga mga klase-klase nga mga radiation nga kani siya nga film or kani siya nga photographic film nga detectors? Ionizing radiation. Photographic film darken on exposure to ionizing radiation and its indicator of the presence of radioactivity. Kibali, mura lang ni siya muganan ni siya once nga mura siya naa siya makuha bitaw nga dark. Something nga mo dark siya pareha sa X-ray. Di ba nakabantay mo anang X-ray? Which means ang X-ray is kana bitaw siya mura siya itom, mura siya i-draw, pero bitaw i-reflect ang naa sa imong lawas, ma-reflect dito sa film. Mao na siya ang presence sa radioactivity. And when Henry Becquerel investigated the newly discovered X-ray in 1896, it led to studies of how uranium salt are affected by the light. By accident, he discovered the uranium salt spontaneously emit a penetrating radiation that can be registered on a photographic film. So, ang number 1 contributor ani nga photographic film is si Henry Becquerel. So, siya ang nag-discover ani siya, or siya ang pioneer ani nga photographic film.
Radiation workers are required to wear a sealed badge containing a photographic film. The film is replaced and developed at regular intervals of time, and the amount of blackening of the film indicates the level of exposure. Chemicals in the film react to the radiation, show the level of radiation the person was exposed to. If the level is too high, the working area must be checked for leakage of radiation and the workers must go for a medical checkup. The disadvantage of this type of monitoring is in the case of an accidental large exposure where the individual would not know the extent of the exposure until the film is replaced and developed. Thank you for taking time to watch this.
The second detectors, we have Geiger-Müller tube and counter, or also known as GM tube. A German physicist, Hans Wilhelm Geiger, in 1908, Geiger introduced the first successful detectors of individual alpha particles. Later version of this counter were able to count beta particles and other ionizing radiation. Kani siya is Geiger-Müller. Ang first, the detectors pa ni siya sa first is ang alpha lang nga particles. But, in a later version, nagkaanam siya ka-develop until makakount na siya og beta particles and then any particles na dayon nga mo-ionize makount na dayon niya. The Geiger-Müller or GM tube makes use of these facts. It detects the emission of nuclear radiation of alpha, beta, and gamma rays by an ionization produced in a low-pressure gas in a GM tube and produce an easily measured current pulse which pass to the processing electronics. Kani man gid siya is mura siya tube. Nga ang isa ka tube is napuno siya og argon gases. Which is kung mo enter na dito sa mura glass is naa siya mga charge dito sa sulod na ay negative, na ay positive, naa siya murag wire sa tunga, something. Masabtan lang ninyo na siya karon kay pagkahuman ani akong video, pagkahuman aning report na ako is i-flash na ako ang video. This instrument is portable instrument choice for a general laboratory radioactive material survey. However, this instrument is limited by its ineffectiveness for detecting lower energy beta gamma emitters. Kibali kani siya ineffective lang ni siya kung dili kaayo niya ma-detect ang beta or gamma or something alpha kung gamay. Means kanang kuan ba kanang dili kaayo niya ma-detect gamay, limited. This tube is a gas-filled device that when high voltage is applied, creates an electrical pulse when radiation interacts with the walls or gas on the tube. These pulses are converted to reading on the instrument meter, which means kadto siya nga tube is naa siya'y gas nga nag-contain dito which kadto nga gas once nga mo enter dito ang alpha, beta ug gamma is mo detect na dayon siya, which is mo count na dayon siya ug pila ka buok kay kadto siya naman pud to siya instrument meter na pud siya makadetect siya og pila na siya or maka-reading siya ba, makabasa siya unsa nga pila ka energy or pila ka pulse. Mao na siya ang makuan pud nato siya nga naa na siya radiation, which means kay na-detect naman niya di na siya radiation. Mao na siya sa Geiger-Müller tube. How does a radiation work? Giunsa ni pagtrabaho or unsay trabaho? When radiation pass inside the detectors, it cause ionize from gas atom, separating atom into positive ions and electrons, which means kani siya masabtan lang ninyo dito sa video kay ang kani siya is kanang ibale Ang tube is nag-compose na siya dira og gases. Ang pangan ato niya gases is argon gases, which is once nga mo detect na to, unya kadto manggong naa sa tube sa sulod is naa siya mga charge, naa siya positive, naa siya negative, positive, negative, positive, negative. Once nga mo adto na siya dito ay is i-separate na niya, which is mag-ionize na dayon siya.
Muller tube. Geiger-Muller tube is the most versatile, useful and very sensitive detector of all radiations. When GM tube is switched on or the radioactive source is removed, the rate meter displays a reading which is known as the background count rate, which accounts between 20 to 50 per minute. A rate meter usually has a loudspeaker which gives a click for each pulse. The Geiger-Muller tube has two electrodes across which a voltage of about 400 volts is applied. A central wire acts as the anode while the cylindrical middle wall of the tube forms the cathode. The tube is filled with argon gas at low pressure. It has a thin mica window at one end through which radiation can enter. When radiation enters the tube, it produces argon ions and electrons. These are accelerated towards the respective electrodes. These accelerated electrons will collide with other argon atoms, causing further ionization, producing an avalanche of electrons. On reaching the electrodes, the ions produced a current pulse which is amplified and fed either to a scalar or a rate meter. Thank you for taking time to watch this.
The third one is scintillation detectors. So, the contributors of scintillation detectors is Sir Samuel Curran, a recognized world leader in his field, invented the two basic techniques for the detection of passage of elementary particles, the scintillation counter and the proportion counter, that detection of the radiation source. So, ang pioneer sa scintillation detectors is si Sir William Curran. These scintillation detectors are used for determination of the high energy part of X-ray spectrum. In scintillation detectors, the materials of the detector is extended to luminescent emission of visible light photons by the absorbed photons or particles. Where are scintillation detector used? Scintillation counters are widely used in radiation protection, EC, of radioactive materials and physics research, because they can be inexpensively yet with a good quantum efficiency, and can measure both intensity of the energy of incident. What are the benefits of scintillation detectors? Some of the main benefits include high sensitivity of detection efficiency, fast response, allowing for detection of the short-lived events, or high counting rates. Is Geiger-Muller counter a scintillation detector? Ang katubang first nga akong gidiscuss ug karon nga akong gidiscuss, pareha ra ba? Or naba sila, or pareha gyud, even pareha sila? The explanation is kani. The Geiger-Muller counter can detect all kind of radiation such as alpha, beta, gamma rays. So ang Geiger-Muller tube is makadetect siya mapa alpha, beta, or gamma rays. Whereas ang scintillation counter can detect only ionizing radiation, which is ang scintillation is limited lang iyang ma-detect, which is kana rang only ionizing radiation. Kung dili mag-ionize, di siya ka-detect. But ang Geiger-Müller tube is maka-detect siya bisan unsa pa na diha nga radiation, nga pa alpha, beta, or gamma. What is the process of scintillation? The process in which energy from a certain radiation interact with the volume of sensitivity material called a scintillator is converted into electromagnetic wave.
On measuring the ionizing radiations by using excitation effect of incident radiation on scintillation material and detecting the resultant light pulse. Coming to the construction of this, here it consists of a phosphorus or you can say scintillation chamber, and this is a phosphorus material made up of sodium iodide or sodium iodide with 0.5% thallium iodide or zinc sulfide, and it is connected with the photocathode. It is made up of cesium antimony alloy, and this whole tube is a photomultiplied tube. और इस photomultiplied tube में आपके डायनोड्स होंगे. these are called the dynodes basically. first dynode जो होगा आपका 100 voltage पे होगा, second dynode will be at 200 voltage, third one is the 300 and so on. और इनसे जो secondary electrons होंगे वो आपके multiply होंगे आपके. basically these are known as photomultiplier or electron multiplier, and this is connected with the amplifier and output pulse. कंस्ट्रक्शन भी हम यहीं पे, कंस्ट्रक्शन के साथ साथ आप इसका वर्किंग भी यहीं पे डिस्कस कर लेते हैं. तो जो भी आपका रेडिएशन होगा जो इस पे फॉल होगा, किस पे, इस मटेरियल पे, दैट इज़ कॉल्ड ए फोस्फोर्स. फोस्फोर्स में आपका सोडियम आयोडाइड ऑलरेडी हम बता चुके हैं. सोडियम आयोडाइड भी हो सकता है. सोडियम आयोडाइड के साथ आपका थैलियम आयोडाइड 0.5% भी हो सकता है. थैलियम आयोडाइड बेसिकली इसमें एक प्रोमोटर और एक्टिवेटर का काम करता है. और जैसे रेडिएशन, हाई एनर्जी रेडिएशन इस सब्सटेंस पे फॉल होगा, द सब्सटेंस इट विल बी एक्साइटेड एंड डी एक्साइटेड एंड इट विल प्रोड्यूस लाइट रेडिएशन. और जो लाइट रेडिएशन आपका प्रोड्यूस हुआ, इट विल फॉल टू द फोटोकैथोड मेड अप ऑफ सीजियम एंड एंटीमनी अलॉय, एंड दिस विल प्रोड्यूस इलेक्ट्रॉन. इलेक्ट्रॉन आपका बीम यहाँ पे डॉटेड में दिखाया गया है, एंड दीज आर कॉल्ड द प्राइमरी इलेक्ट्रॉन. And primary electron are made to incident over this Fuchsing dynode. Dynode क्या करेगा, secondary electron produce करेगा due to photoelectric effect, and these are multiplied. Number of electron will be produced will increases, and in the last there is a anode. तो जो आपके इलेक्ट्रॉन्स, सेकेंडरी इलेक्ट्रॉन्स आपके जनरेट हुए हैं, लास्ट में उनका एक बीम हमें मिलेगा और उसको हम एनोड पे कलेक्ट करेंगे. एंड जो भी इलेक्ट्रॉन हमें गेन होंगे वो एम्पलीफायर से एम्पलीफाई करेंगे और आउटपुट डिस्प्ले में हम गेन करेंगे आउटपुट पल्स. सो जो आउटपुट पल्स हमें मिलेगा इधर, वो आपका डायरेक्टली प्रोपोर्शनल होगा द लाइट रेडिएशंस और number of counts falling over this phosphor.
The fourth one is cloud chamber. Charles Thomson Reines Wilson, he invented the cloud chamber. The device was switched on for the first time in 1911. Almost 20 years of development. Originally developed between 1896 and 1912. A cloud chamber is an enclosure containing a supersaturated vapor of water alcohol. Radiation entering the chamber causes ionization, and these ions acts as condensation Lucy, around which tiny clouds are formed because the vapors are near a point of condensation. These nuclei lead tracks of the radiation. What is the purpose of cloud chamber? What's the purpose sa cloud chamber? Is a device used to detect ionizing particles and to determine their trajectory. It does not show the particles themselves, but where they have been. Particles from a condensation trailed in a chamber which is visible as fine mist, and this shows the particles pattern through the chamber.
Radioactive detectors, cloud chamber. A cloud chamber enables the tracks of nuclear radiation to be seen. Cloud chamber is the most useful for studying alpha particles because it has the strongest ionizing effect. A felt ring inside the top of the chamber is soaked with alcohol. Alcohol in the felt ring is vaporized and cooled by dry ice at about -78 degrees Celsius to become supersaturated. Radioactive radiation passes through the vapor and causes ionization of vapor. The formed ions act as condensation nuclei, condense the surrounding to become supercooled and supersaturated vapor. The surrounding mixture of air and alcohol vapor forms a mist. The high energies of alpha particles leave trails of track behind due to ions produced along its path. Tracks can be seen through the transparent perspex lid. Different radiations produce different radioactive tracks as seen in a cloud chamber. Alpha particles produce straight, thick tracks which are of about the same length. Beta particles produce thinner and twisted tracks. Gamma rays produce thin, short and irregular tracks.